Hi guys, good afternoon. So in the last session we went with the iOS C server based site-to-site VPN. Now so far whatever the VPNs we have discussed, okay, although your VPN syllabus is already completed, okay. So far whatever the VPNs we have completed, they are all L3 based VPNs. L3 based VPNs, correct? So today what we'll see is we will see a layer 2 based VPN technology. Okay. Now in the layer 2 based you can talk about your L2TP or you can go to the MPLS. Now MPLS you have already studied in your advance. If you have not, then you study in the advance. L2TP I will tell you. Okay. So the current version, the latest version right now we have is L2TP version 3. So this is nothing but it's a layer 2 based VPN technology. Okay. So here also see this will be kind of working like the same only. Okay. We are going to here also the L2TP tunnel that will be created, same like GRE, it will not provide you any sort of encryption or anything. Okay, there will be no encryption at all. So for encryption and for security, again, what we will be using? We will be using IPsec. Now in IPsec, you can go with the IPv1. So directly we'll go and see the implementation of your L2TP version 3. Okay. So, now, according to CCA exam, again here I'm going to use the CSR routers in this VPN implementation also. Okay. Internet issue. I'll just turn off the CH class. Okay, login. Here we'll power off Kali. Okay. And I'll power on ENG. User. Close the lab. Create a new lab. Here we will say L2TP stands for Layer 2 Tunneling Protocol. So first thing, we'll take a switch. Have you seen the CCI lab topology? How does it look like? Same, right? Many routers and switches. Let me give you a glimpse of it. The version 6 topology I'll show you. This is the topology. Okay. And this is the entire topology. You can see it. Okay. And this is the topology you have to configure. Now in this topology, where is the L2TP? Okay. See, like this is the switch. And this switch here, EIGRP is running. And on this router here, EIGRP is running. Do you see the same autonomous system number? Then the network is also same. Okay. And here between these two routers, here we will configure the GRE tunnel. We will apply the IPsec security, and then we will apply what? Your L2TP. So for L2TPC, we will use this interface, this side interface, switch side interface, and the interface on the other side. Okay. So on these two interfaces, we will not be configuring any IP address. Okay, there will be no IP address configuration here. You can see on every interface IP addresses are mentioned, but on this interface there is no IP address mentioned. Same way on G4, no IP address mentioned. Okay, because we will not be configuring any IP addresses on these two interfaces. And then here EIGRP, same autonomous system. Network is also same. So that means if our VPN tunnel will set up here between G3 and G4, if my VPN tunnel will set up, so my EIGRP neighborship should form. Because as soon as my L2TP configuration will happen, these two networks, they will become like directly connected. This is layer 2 based tunnel. That means in between no routing kind of thing. Okay. So if the EIGRP neighborship will come up, and if I will be able to ping from this interface to the switch, that means my L2TP VPN will be success. Got the overall idea? Now we will design only this mesh topology. We will take one switch and three routers. We will take what? Three routers. Is that clear? Okay. Yeah. Okay. And same way you can see here in FTD you studied side to side VPN, right? See here. This is FTD1, FTD2. What you have to configure here? So whatever you study is there in the exam. Okay. ASA you studied, right? ASA. This is HA, right? So whatever the concepts you study, everything is there in the exam. Okay. So this is the switch I have taken. Then I'll take routers 3. So what? CSR routers. 3 routers I'll take. And we have 20 GB, right? So 4 CPUs to each router I'll assign so that it will work faster. Okay. So 4 3 is 12. Let's go with 15. 5. Super fast. Okay, this is how our lab will be there. This is how our lab will be. And if you see it according to the exam topology, this router, if you consider L-set topology. Okay, so let's bring it up. Okay, IP addresses will not use according to the exam. We'll use what we have been already using, so that it will be easier for you to remember also, understand also. Okay. EIGRP will be between this switch and this router. And IP address we will not configure on this CSR3 and CSR2. Okay. First, understand, let me mention this. That interface will not provide with IP address. So on the router, we will not provide IP address, right? On the switch, we will provide IP address. Okay. Yeah, layer switch. The second is router. See, in exam, these router names are what? If you look, I'm giving normal R1, R2, R3. As exam perspective, R16, R5, and R4. Okay. Then their subnets are like 100.0, 172.16.100.0, 10.10.100.0. These are their subnets. Okay, so instead of this 10.10.100.0, I'll use 10.10.10. Here, cloud. This is ISP. Hmm? No need to use, because even ISP will provide you eventual connectivity only. Okay. Which one? No, no, ISP no need to configure. Okay. See, I'm using the interface G1 this side. Okay. Then I'm using G2 this side. Okay. This is G1. Then again here I have. Okay. Interfaces are connected. Now let's start all these nodes so that by meanwhile when we'll mention the IP address and everything, these devices will come up. Okay. So now this is what we are configuring this L2TP VPN. Normal. Say okay. Okay. Now here, if you look at the subnet here, it's 10.10.100.0. So in place of this, we will use what we have been using, 10.1.1.0 or 10.10.1.0, whatever it is. Flash 24. This is done. Okay. Now from this subnet, if I want to assign the IP address, so on R1, IP address I will assign is .1. Okay. And on R2, what is the IP I will assign is .2. This is clear. Okay. Now here, like I said, we will configure what GRE also. Okay, so let me just keep this IP addresses on the other side. Okay. So here we will configure what? GRE, right? And now for security purpose, what we will use? IPsec. IPsec. Now, if you want, you can go with IPsec version 1 also, version 2 also. That is your choice. Okay. In this case, according to exam perspective, IKV2. Okay. And the tunnel subnet that we are using here. Now, if you look at the tunnel subnet here, what is the tunnel subnet? 100.0. We will use it 1.0. Okay. 1.1.0/20. To 16.1.1. That will come here. And 1.2 on the other side. This is clear. This is the tunnel subnet. We will configure here and here. Now, like I said, that on R3 and this switch, we will configure what EIGRP. And for EIGRP configuration, the subnet we are having 192.168, 100.0, we will use it 1.0. Okay. So we will configure on the this R3 and the R1, not the R1, sorry, switch. Okay. So see here, what is the configuration we are talking about? Here, I'll configure 192.168. 1.0/24 is the network. Okay. And autonomous system number, let's say we'll use EIGRP 10. Okay. Here we will use EIGRP 10. And from this subnet, the IP address that I will use here. So this is R3. This is clear. Same subnet here. An IP address, this is switch. So let's say on the switch, I'll configure something like .1. This is clear. Now these two are in the same autonomous system, correct? And these two are in the same network. So when we will advertise in the EIGRP the network 1.0 and network 1.0, they should form a neighborship. Neighborship should come out. Okay. All right. So first of all, let's go for the basic configuration. So first, let's go for the switch basic configuration. Okay. So on the switch, we will say enable configuration terminal. Host name by default switch. So interface 0/0. And here I will give a command no switch port. Because by default the port will behave as L2. So when I say no switch port, L2 characteristics will be turned off and this port will behave like L3. So I can assign IP address also. This you can use a router also, no problem. I am showing you according to this topology exam. Okay. No, not required. When we will configure it. This is enough. Right now, I just want no switch port to make this port behave as L3. On this port, I don't need IP routing command. Wait for it. IP address 192.168.1.1 255.255.255.0 and then no shutdown. Then what I'll do, I'll configure EIGRP here. Say router EIGRP 10 and we'll say network and I want to advertise what 1.3. No, to somebody no, because this is class full only. Class C default mask, no problem. Right now, let's use this much. Okay. Now, this configuration is done. Let's go for the vector R1. Now R1 enable configuration terminal. The R1, then interface G1 I will not assign with the IP address. So I'll assign IP1. G2 say IP address 111 255 and say no shutdown. This is clear. Okay. Now here we don't need to configure any edge IP. Why? Because it's directly connected. Okay. All right. So this is done. After that, we will configure what? R2. If you want, we need to bring it up. So right now itself, if you want to do it, I was about to do it later. But if you want to do it right now, you can say interface G1. Then I don't want to assign IP address, or what I'll say? No IP address. So that whatever, if by default also taking, remove it. And then no shutdown. Now let's go for R2. So enable configuration terminal, host name R2, then interface G1, IP address 10.112, interface G2, address, no shutdown. This is done. Okay. And then R3. Okay. On R3, we'll say enable configuration terminal, host name R3. And then we'll say interface G1, IP address 192.168.1.3 no shutdown. And then router EIGRP 10 network, and we will say 192.168.1.0. Because here this is class C and it will take class full network by default. So it is same thing, right? That's why. If you want, you can do also. Totally fine. Okay, this is the basic configuration done. Okay. Now let me access all these devices. Switch. And this is the switch. Then R1, R2, then R3. Okay. Switch is up. Here we will say no. Then we will say yes. No. Yes. No. Now let's paste the configurations one by one. First of all, switch configuration. Copy. Done. Interface status up. Okay. R1. Copy. Paste. And then R2. Copy. Paste. Then R3. So here one more thing you can see that here I have identical subnet, correct? So normally earlier when we were talking about identical subnets, what was the VPN we studied? overlapping. We had to go through the NAT and all. Here we don't need that stuff. In L2TP, direct communication. Okay. Now see here. This is done. So first thing we will test is public to public connectivity. That means R1 to R2 connectivity, since they are directly connected. We should communicate. Do print 10.1.1.2. So I should have the communication. So yes, I do have the communication. Okay. If I try to ping from R1 to this, will I be able to ping? Switch. No. Why? Hmm? There is no IP address. Same way from here I cannot test the connectivity here also. Okay. Now the next thing we'll do is what we are going to go and configure tunnel. The tunnel interfaces we will configure. Okay. So R1 and R2. Okay. So let's go and configure it. 10 devices. Configure tunnel interfaces. So first of all, R1 interface, tunnel 1, source. Who will be this tunnel source? If you want to not 0 Z0 by 2 also, Z2. Okay. So as of now, you can mention IP address or anything we always know, right? Then I can say what is my tunnel destination? My tunnel destination will be destination. Destination will always be IP address only, not interface. Source you can give an interface. Destination will be IP address. Huh. That is totally fine. IP address is IP address only. Then we can say IP address 172.16.1.1.255.255.2. Then no need of no shutdown. This is a virtual interface. Same thing in the R2. Source will be 2. Destination will be 1. This IP will be that path we have to. Let's copy paste. Now here, copy this configuration, paste this configuration. Then copy this configuration and paste this configuration. And now you should have communication to your tunnel interface also, right? So let's see 172.16.1.2. So I should have the communication and we have the communication. Now once this is done, so first of all, see, first step is basic configuration. Second step, your tunnel configuration. Step number 3, you will configure now L2TP. Okay. So let's go and configure L2TP. First of all, we will go on R1. Okay. On R1, we have a command. Here, I have a command sudo wire class, and we have to name it. Okay. So right now we are configuring L2TP. So let's name it what? L2TP only. Then in this, what do we have to mention? We have to mention what? Encapsulation. So I'll see encapsulation. What is the encapsulation I want to use? You see, I have L2TP version 2, I have L2TP version 3, as well as I have MPLS option. So MPLS is also what? Layer 2 VPN only. But right now we will go with the L2TP version 3. L2TP V3. Okay. Then question mark. As soon as see earlier when I checked using the question mark, I was having few options only. Right now I have more options. So now I can specify what? IP parameters. So I'll say IP. Now I have some options. Okay. Protocol, TTL. So I'm specifying local information on it because I will be using my tunnel interface for communication. So I will say IP local interface. And what is my interface name? Tunnel 1. Interface is tunnel 1 because I want my L2TP communication via the tunnel. Right? Done? Okay. Now this is done. Now we will go to the interface from where we want to initiate the L2TP setup. So I want to initiate my L2TP setup from here to here, so that these two subnets they can directly communicate. That means this time we are considering the ports where we did not assign the IP addresses. Why we did not assign? Because these ports I want them to behave as a L2. So L2 means no IP address, and that's why on these interfaces we did not configure any IP address. Correct? So what we will say here, what is the interface on R1? G1. Okay. So I'll go to that interface. And here, see, so many different commands will be there on the interface. We have to use a command that is xconnect. Okay. I have to say xconnect. Now what I have to give my peer IP address. Now what will be my peer IP address? I'm using tunnel interface. Remember, I'm using tunnel interface. So my peer will be what? 1.2. Okay. 172.16.1.2. Then I have to give some ID. So let's say any random value I will take. Let's say 100. Then I have to give two things. One is encapsulation and second is pseudo wire class. Remember pseudo wire class already we created with the name L2TP. And encapsulation, what is the encapsulation we are using? Encapsulation we are using right now L2TP version 3. L2TP version 3. And now I will give the pseudo wire class. Pseudo wire class, what is the name? L2TP. So L2TP. This is done. Okay. And do you see that the line protocol on a interface pseudo wire 0 change state to up? That means again a virtual interface or a pseudo wire interface has been created that will be used for L2TP communication. So this side configuration is done. What are the commands we used? Configure L2TP. So on R1 we said from beginning, let's take the comments. Pseudo wire class. L2TP. Then inside this, what did we give? Encapsulation. After encapsulation, we gave the IP parameter. Right? And then after we say, that's it. Once this was done, we went to the interface. Okay. On the interface G1, we use the xconnect command. This is the xconnect command we used. Okay. Now this is the command we use. Same sort of configuration we will do here on the R2 also. So copy this configuration and paste it again. Now, whatever the changes we have to make, those changes we will make. Here any change? No, only here IP change. This is done, and this is to configuration. And interface will change. If you look at the interface on R2, interface is G2. Now copy this. And this configuration is copied. Now let's paste this configuration on the R2. Pasted. All right. This is pasted. So now shut down R1. Although these G1 interfaces are already up. And do you see, as soon as I give the no shutdown command, do you see what happened? Your L2TP is a success. Okay. So you can say after this, you will say one command, no shutdown. And here also, what it is. This is your L2TP configuration. Okay. Now, right now, this traffic is insecure. So we can do what? We can go and apply security. IPsec we can apply. But you can see our L2TP is already a success right now. Okay. I can go and check. So IP EHRP neighbors, and you can see 1.3 is what? My neighbor. And if I want the communication, I can say ping 1.3. My L2TP is already a success right now. Okay. Now, if you want to have the communication securely, okay, so that communication will be secured on this tunnel between R1 and R2 only. Okay. So if you want to secure the communication,
now R1 and R2
no, it will come encapsulated with L2TP. So right now, if I go and capture the packet, see here on the G1 interface, if I capture the packets, okay, so you will see that all the packets, they will come encapsulated with the L2TP protocol. This is R3. So from R3, I will ping, I'll say 192.168.1.1. I have the communication. So do you see it is showing this kind of protocol? Okay. Do you see here? What is the protocol? L2TP version 3. So this entire communication will happen like this only. And you can see all the packets, they are encapsulated with L2TP. Is that clear? Now, right now we are having this GRE header. We can configure SVTI, tunnel mode, IPsec, IPv4. And then what will happen? This GRE header will be removed. Right? But for that, we need to configure what? IPsec. This is clear. So right now, all the packets, they are getting encapsulated with your L2TP. Okay. Then you can see inside the Cisco frames are there, whatever the communication is going on. All these packets are encapsulated with L2TP. Here you can see. Clear? Okay. And when you check the communication, okay, at R3 and switch, so here your communication will be totally unencrypted. Like let's say I will capture on like G2 I will capture this time. Okay. So if I capture G2, you can see all the packets are unencrypted. Clearly you can see EHRP. Right? And if I will ping, that also you can verify. You will see ICMP. Clear? Yes or no? Now, if I want that, okay, the communication between R1 and R2, whenever my data is traveling between R1 and R2, that communication should be secured, so I can apply IPsec. So let's go and configure IPsec now. Configure IPsec. Now, if you want to configure IKv2, we already have the commands here. VPN 2 PM, GRE route based, IKv2. Here are the commands. Tunnel we configured. See, we can say crypto IKv2 proposal. Okay. Then policy you can configure the keyring, and then you can configure the profile. And in the profile, we can attach the keyring. And here, what was happening? That here we had to give, pre-shared key local one, pre-shared key remote. These all commands multiple times we have to keep. Now, when you want to configure it, like in the Flex VPN, what happens that we don't have to configure almost everything. Okay, so we can reduce some parameters also. How? See here. We can say crypto. First of all, this is configuration on R1. Now I can say crypto this is R1, right? What we can say here? Let's come here. So IKv2, and I can directly go and configure what? My keyring. Name it what? Cisco. Now here I need to mention what my peer. My peer is what? R2. My peer is R2. Then I have to configure address. What is my peer address? 10.1.1.2. Because when we configure VPN, we give public address. So this is my peer IP address. And after that, I can directly share what? Pre-shared key. And what is the key I want to share? Cisco. Can say exit. Then I can say to the keyring only. To IKv2 profile, and let's name it or let's name it profile 1 simple. Profile 1. Now here we have to give a local and remote authentication, as well as we have to match identity or certificate. So I would say first of all, match identity, remote address, and we have to give the address. So remote address is 10.1.1.2, 255.255.255. Single address it is, right? Submit mask. This is done. Other than this, we can configure addresses or see two things it was asking, right? One is identity and second is authentication. Authentication, local and pre-shared. Authentication, remote, pre-shared. Okay. And then here we can say the key link is local. And what was the key link name? Cisco. Done. Crypto, IPsec, Profile, VPN profile. And here we will attach the IKv2 profile. Okay. That is in the tunnel interface. I'll show you. So you can say set IKv2 profile. What was the profile name? Profile 1. Okay. And this IPsec profile name is VPN profile. So this profile we will apply it on the interface. Interface tunnel 1. And we will say what? Tunnel protection IPsec profile. And what was the profile name? And here itself we can say tunnel port IPsec IPv4. This is your SVT to remove the GRE header also. Okay. And similar comments for the other side also. So what are the comments we configured here? IPsec pre-shared. Okay. Router you cannot say show history. This is running config it will show you. Okay. Yeah, we can check this thing right. Section IKEv2. ASA. Yeah, that is for ASA. Eating Cisco, peer, pre-shared key, these things we here configure this. Then before that, we configured IKv2 profile. Match address, local authentication, remote authentication. And then keyring we configured. We configured then IPsec profile. One section. This will come in the IPsec profile, right? See here, set IKv2 profile. This is a part of IPsec configuration. Same like this, these two commands are on the tunnel interface. This is what we have done. And then we can say tunnel 1 and then these two commands. Then same configuration we will do it on the R2. What are the things that are going to change? Address here will become R1. IP will be 10.1.1. Here will be 10.1.1. Nothing else. Okay. Tunnel interface is same only. Copy. Right now, do you see my EIGRP neighborship down because one side VPN configure, one side not configured. Now, once we configure on the other side, the VPN configuration will be done. The ISA camp on, tunnel interface on, EIGRP neighborship should come up now. Wait for it to come up. So is the tunnel being established? Tunnel interfaces are up. Let's say ping 172.16.1.2. How the communication. Something is wrong. Okay. Okay. Tunnel interfaces are up, but tunnel interfaces are not able to communicate. True. True. Right. Okay. Tunnel is ready. Now get to 172.16. Okay. See, it has started. The packets are going here. Communication are not having. 192.168.1.3. Use your neighbors at this time. To run it, interface, tunnel source, tunnel destination, VPN profile, to run interface, tunnel one. 1 minute, let's remove the tunnel protection. This tunnel one. Here also. Tunnel one. ISA camp is off. And if ISA camp is off, here neighbors interface G1, no shutdown. Interface G2, no shutdown. Tunnel one, no. Right is ID. Tunnel one. See, L2TP is not a problem. Right now, I'm removing the tunnel protection. My tunnel interfaces are up. Now, if I test the communication between the tunnel interfaces, do ping 1.2. I have the communication. But still, the ARP neighbors is also up. Then what is the issue with the VPN configuration? I think we have configured. The share key is also there. I gave it to profile one local key in Cisco. So L2TP wise configuration is okay. Peer address is fine. Peer remote address is fine. Let me try these commands once again. Copy, paste, copy, paste. Tunnel interface is up. Tunnel interface is up. What about the communication here? Ping 192.168.1.3. Same configuration. See, might be because one by one line I did the configuration. That could be a reason. So right now I pasted all the configuration. Same configuration without any change. So now it's working very fine. Communication is very proper. And you can say entire communication is from ESP protocol. And these are the child essay was initiated, right? No, not GUI based. Routers will be CLI based. But yes, configuration wise, if you are going with the local networks, then DNAC kind of things, if they are there in your organization, then centrally you will sit in one place. And like FTD, you will have like FMC, you have DNAC, centralized device. So there you will type down everything and configurations will be pushed automatically. Okay. So right now you can see our communication is very fine. This was your L2TP. So other than IPsec, if you see L2TP configuration is this one. Okay. That you create a pseudo-wire class, you define the encapsulation that you will use L2TP version 3, and through which interface you will have the communication. Okay. Then after whatever the interface you have not assigned with the IP address you want to use for L2TP communication, that interface you will use the xconnect command and you will give your peer IP, then ID you will give, encapsulation you will say, and the pseudo-wire class that you have created here. The same pseudo-wire class and same encapsulation you will mention here. And then you will just say no shutdown. So this is all the configuration. Is that clear? So with this, VPN is done. This is your L2TP set IGV. Clear? All right, people. So how many VPN configurations have we completed? 2020. These are the total configurations we have done. 21 is there. One in the, I think, DM VPN, one is missing. In DM VPN, one is missing. Where? Oh, yes, I didn't get time to check. You have to remind me, otherwise I forget. Yeah, not midnight. Okay. All right, guys. So this was your VPN. Monday we'll start with ESA.